Good morning, Night City? No, wait. Wrong game. Morning, everyone. Or well, afternoon. Let's go for some more Advent of Code. Your ferry can make it safely to a nearby port, but it won't get much further. When you call to book another ship, you discover that no ships embark from the port to your vacation island. You need to get it from the port to the nearest airport. Music is still out, alright. Fortunately, a shuttle bus service is available to bring you from the seaport to the airport. Each bus has an ID number that also indicates how often it leaves for the airport. Bus schedules are defined based on a timestamp that measures the numbers of minutes since some fixed reference point in the past. And the timestamp 0, every bus simultaneously departed. After that, each bus travels to the airport, then other locations, and finally returns to repeat its journey forever. The time this loops takes, a particular bus has its ID number. The bus with ID 5 departs at 5, 10, 15, etc. If you're there when the bus departs, you can ride that bus to the airport. Your notes consist of 2 lines. The first line is your estimate of the earliest timestamp you could depart on the bus. The second line lists the bus cities that are in service according to the shuttle company. Entries that show X must be out of service, so I decided to ignore them. To save time once you arrive, your goal is to figure out the earliest bus you can take to the airport. There will be exactly one such bus. For example, suppose you have the following notes. The earliest time for you could depart is 9:39. The bus IDs in the service are 7, 13, 59, 31, and 19. So the first one would be bus 59. Never suddenly minutes waits for the bus. Okay. Let me grab the text file. So, int time departure is int, and then inputs. So that's the first one. And that would where let me actually close all the other stuff for now. So we don't need to do much IO. Yeah, sure, save that. 7, 13x. Yeah. Well, that's fairly easy. So what we're gonna have is a vector of times. Well, let's say it's schedules. And we're gonna have an int dummy. And what we're gonna do is we're gonna do inputs dummy. And then we're gonna do schedules dot pushback dummy. And then we need an int, we need a char discard. Because we need to discard the comma, so then we do inputs discard, and then we need to because there's always going to be one, and then we need to, because then we know that there's going to be. Then I can do this while inputs dummy, sorry, discard. There we go. On day 13, hamster turned to heart. Wait, what? Why? Though I still programmed practical and actual solution before you. Why? That means nothing, hamster. Like, it's very nice that you want to show how much superior you are to me, but when you start earlier, it's not relevant. Just make sure we did it right. Man, what a surprise, you beat me in a race because I didn't even start yet. Let's see. Oh, this will error out, actually. Yeah, this will error out. Well, let me just say that there's a site that can do difficult part of part 2 for you. Huh? Well, I'd rather not. No, so dummy needs to be a string. Modulus math. Oh, it's gonna be modulus math? So it's gonna be a string. And they basically do if dummy does not equal x. Actually, it's a char as well. So just to make sure it doesn't consume everything. So if it doesn't equal that, pushback, was it stoy? Stoy dummy. Wait, no, because it needs to be a... that's annoying. Because it'll only grab the first character, but if it's a string, it'll consume the entire thing. That's annoying. I think I wrote a delimiter somewhere. So I can just use that. If you don't, well, we'll see if I can figure it out. If I don't, then I'll ask for help. What? This is really annoying. I know how to do this in Python, but I don't know here. Twist, no. Hot hash, not hash. Smart way to do this. Fine. Fuck it, I'll just look it up again. Stream. Yeah, with delimiter, using stream delimiter. Yeah. It's something like this. Count token, yeah. This one's not nice because it'll output the last one outside the loop. It's really annoying. Getline is preferred, but the issue here is that you have like this can't be parsed as an X. But I was thinking like, okay, if I can do this as a char, it'll just consume just the 7, just the 1, just the 5. That won't work. And there's no way to... Is there a try or something? You can set the delimiter. Wait, what? Really? Okay. Oh, I guess it just defaults to /n. I see. Yeah, you're right. Input field delimiter. Yes. Let's do that. What does it get put into? Was it a... It reads string. Oh, yeah, that was it, right? String. Wait, I used getLine before. Not very difficult. Yeah, input is just and then the X. Yeah. Just so I know what I'm dealing with. Nothing. So because the first What? Well, first of all, Nitro, do that maybe. There we go. Thank you. Could you actually code departure as well? Yeah, got that right. All right, so then it's fairly easy. Oh, it's a string, right? So and typing is difficult. There we go. 7, 13, 59, 31, 19. Just correct. So now what do? Is we basically for every single one. So what we do is we make another vector. We make another vector int that is called weight times, which is of the size of schedule stub length size. And basically we then take the minimum, and we just need the index of that, which is fairly easy. So now I just calculate it. I don't even need to do it. You just push back. It's fairly easy. So I need to find n for which. Well, so that's just departure over that plus 1, then modulus, right? And then just the modulus. Do I just do the modulus of itself already? Count. 1, 3, a whole fucking bunch. Yeah, and then it's just so we do and this is the wait times. You just do the minimum of that. Yeah, and then I just need to get the index there. Can you? It's fairly easy. Think you'll have fun, get frustrated, part 2, looking forward to it. Thank you. Anyway, you just need to get the answer here. Int min equals 999. Actually, it'll be departure at most. Departure to int waiting equals this. We don't even need to keep track of it. Just need to do an index as well. If, oh yeah, need to actually do that as well as, sure. If waiting is under min, let's see, int mindex equals -1. Something will have to be below it. Yes, I know it won't work. So I have to change this a bit. So what is it gonna be? 5 by the bus ID, so that'll be min times schedules. Oh, actually, this is stupid. Oh, go away. It's V. What are you complaining about? I am. $295. That's a lot of X's, good lord. Alright, we're gonna have to do something with those X's. I am so sure of it. That seems very low. 370. Early, right though? Yeah. The shuttle company is running a contest. 1 gold coin for anyone that can find the earliest timestamp such that the first bus ID departs at a time, and that each subsequent listed bus ID departs at the subsequent minutes. The first line is no longer relevant. For our example, suppose you have the same list of bus IDs as above, 713XX. You should look for the earliest timestamp, T, such that the 7 leaves at timestamp T, 1 minute after timestamp T. There are no parts of 2 or 3 minutes, 6 and 7. Wait, the fuck? Jesus Christ, you're... Okay. Oh shite, that is awful. My first instinct is hard code a clock. Or I was a dream coming to solve it. Well, let's just do here. Part 1. So we need to find an int n such that let's see, let's actually type this. Find n such that lucid dream if I was doing this question, but sort of. Find n such that for each pair, which would just be an index, comma value. Sorry, find t. Let's do it that way. Find t such that for each pair, v modulus t equals I. That is right. Yeah, so the index, so the... Oh no, it's actually this thing, so it's actually, first of all, it's v minus t modulus v. Oh, good God, is I, yeah. There's no remainder here, so it's 0. Or will the remainder be 7 here? Let's see. Oh, nice. We actually get some more help. Surely actually would be larger than a fudging huge number. Okay. So we're dealing with multiple cycles here. So my input is huge. It's mostly like, yeah, that's what those X's are for. a nice 631 in there. There's no naive way you can't do it. Good grief. My solution's significantly large. You need to be efficient. Yeah, and I already realized, like, when they say something like it'll be larger than whatever. Like, the moment you can't count the zeros easily, you already know you can't brute force it. There has to be a smart solution there. So you know it has to be a multiple of this number. So that's for sure, but that's not. So any approach that I would take here would all involve. Let's see. Okay. So say we increase the timestamp by 1 for each. So we need to find a series of t's basically where that works. So what we can do is so say we have on my solution post in Discord if you do too. I want to see if I can think of something. So we have. Let me grab one of the very easy ones they have here. Yeah, so let me just grab this one as an example for my mind thingies. So I need to find a t such that t mod 17 is 0. T plus 1 t plus 2 mod 13 is 0. And then t plus 3 mod 19 is 0. Where do I have a graphing calculator here? Yeah, just so I can quickly debug this in my mind. And their answer is 3417. So, because I'm pretty sure you can, like, these constraints. Your logic is correct. So these constraints, yeah, I'm just gonna double check it on my calculator. So these constraints will allow us to actually construct a formula that just gives us the right answer, as it were. Modulus. Where the fuck's my modulus? Well, I can just do divide by. It's 201. Was it? 3417. What? Oh wait, yeah, I'm doing it wrong. I'm being stupid. 3417. Where the hell is my modulus button? I'm using a TI-84 here. I can't find it. I pressed the wrong button. I was like, why is my answer weird? Yeah, that's why. Was it in math? No. Where the hell is my modulus button here? I haven't used this thing a lot in like years. What the hell? How can I not find it? I mean, there's always a catalog. And then I have to go to alpha mod MMMMM. There's mod box plot, but not mod. What the hell? I am very confused here. Lambo T84 clearly barely better than a site. Yeah, it's true. I like doing it analog here, but I might as well just use, you know, the inbuilt calculator here. Does that even have mod? Yeah, there we go. There's mod. And 0 as expected. So 3417 plus 2 mods 13, 0. Okay. So these are the constraints we're working on. The thing is, we know that these are all the same, so what in theory I could do is do... Okay, I don't know if a good way to define mod as in... I never work with that in calculus. But it's like a formula such that t minus n times 17 equals 0, with n being an integer, a positive integer. Ergo, t equals n times 17. And the same will be here. So t equals... Also t plus 2. So this will equal n times 13. Plus 2. And so forth. T equals n times 19 plus 3. And these n's are all different, of course. So basically you need to find... Yeah, so it's like plus 0, just to have it correct. So basically need to find the intersection, but these are equal to each other, but the ends are... Well, no, because you can know when they're the same because they have... What do you have to find? Like the inverse... Well, no, so you need to multiply them together, and then you take this, how do you do that? What was it? The smallest common multiple? Something like that? How do you get that again? I know you can get one by just multiplying them together, of course. But I think that's not per se the smallest value. Yeah, least common multiple. My math is too old for this. LCM. Well, they already have a function, nice. What? Look at the numbers. Wait, are they prime? Oh, they're primes! Oh, fuck, it's one of those days. It's one of those days, isn't it? I had that idea before, but I was shook out of it by... Oh, this, yeah, I was like, oh, the answer must... the answer isn't prime. It's always one of those days, yeah. So they are prime. So the least common multiple is just them multiplied together. So then what we do is for this one... So that's the least common multiple of them all multiplied together. But this plus thing is, of course, throwing dirt in the, it's having one of those days. Is good grief. So n times 17 equals n times 3. Oh, let's do n2 just to be proper. Equals n times 13 plus 2. Equals n times 19 plus 3. But then we need to solve a much larger one. I'm probably missing something pretty obvious here. Is it just multiplying them together, all of them? I think it is. It usually is. It's not just multiplying them together. Is it minus them? So it's 17 times 11 times 16? No. Yeah, it's not that easy, of course. It does give me an upper and a lower bound, I guess. Sort of. No. Because this would be the one where they all are on the same... are all on the same timestamp. So now we just need to do... (17 times 13). So that's n plus 2 times 13 plus 2. Yeah. Wait, no, that's not right. 13n plus 2. Yeah, well, no, I already did that as like the plus 3 or something. How about you do the math equations that are trying to guess? Probably not an IDE. My math is too rusty for this. What, it was like matrix operations or something? Pretty sure that would work. Go away. What's wrong with you? You need a 5th grade math level to do this question. I was supposed to say, what is LFT? I'm not sure what that means. Theorem? Yeah, that doesn't help me at all. What was it again here? I'm not gonna look it up just in case. Yeah, I need to dynamically adjust, I know that. Let me see. Just gonna equals to interface about that. So we can get the multiple by the low. That's the other number. That's the other numbers. Little Fermat's theorem. Oh, that one. Also, okay, let me think. So what I need to do is need to know the least common multiple between... Those pluses are throwing me off, though. That's the issue. Because it was simply without the pluses. Yeah, I just don't need you for now, actually. Without the pluses would just simply be the other numbers. Was the other two numbers multiplied together? Was it just itself as well? Yeah, no, it's the other two to multiply together. But the pluses need to go somewhere. I'm thinking about where. Because we already kinda did something like that. 7 over 17 is 201. Leave it to the Russian to be the math nerd. This guy did plasma physics, I think. I just need to find the right things to smash these together. Trinitrotoluene. Nice. 3417. I think I might have found it. So 15. No, the other way around. 7 over 11. Is that it? Hmm. Well, of course I can do the subtraction. No, wait. I think I'm being stupid here. Yeah, I think I'm being stupid here. -2 and then. Wait, no. Yeah, okay. So that's fine. And then over 13 is. Wait, what? The way around? Nitro Streamlabs also uses shitty RE. Wait, what? I have no idea what you're on about. Oh yeah, it's +2. Yeah, over 13 is a whole number. 263. 201, 263. Yeah, it was. But why do you mean Streamlabs? That's it, I think. Let's see the one. It's 180. What is highlighting your name if not Streamlabs? Chatty. So it's not using shitty rejects. I told it to highlight everything that uses that. The software uses crappy rejects. 17 times 321. So these are the n values here that I need. Very roughly calculated. But basically, what I need to figure is a way to figure those out from the numbers themselves. And I'm just throwing some stuff against the wall since my mind is not exactly working proper. For example, 17 times 11 is doing a whole shitload of mental math. But I need to... no, I don't want to code it. It's, for example, 187, 17 times 11. And then... so 17 times... wait, what's 17 times... oh, 17 times 15. 255. That's not it. 17 times 16. 272. Just 9. Oh, wait, no, that makes no sense. There's no sense in coding any of this, because I don't know if there's a solver built in here that I could use. I guess I could just try different ends. I guess that would work. Because then you're at most going towards... no, because the... let me think. You can take the highest number, because you know that the highest number is basically going to be your most restrictive number, and then try to find that n, and that n will be fairly low. Because like in our solution we have like 600, for example. That could work, I guess. Still brute forcing, but it's going to be way, way lower. No, because if they say the answer is over like over that, and our lowest number is like 600, it's still gonna be, you know, over 600. It's still gonna be like 166 trillion or something. There's a better way. There needs to be a better way to do this. Damn it, what's the... I don't get it. At least write the naive solution. It's so straightforward to improving and knowing least common multiples. But isn't it still gonna take fucking ages to calculate, though? No, but the thing is, I still haven't used the least common multiples properly somewhere. It took 2 milliseconds. Well, I'm still not using it in a smart way here. The penny hasn't dropped yet. Because I can just search for the ends, but that's... I still have to do a bunch of checks with all the other ones, which are... That's not that many. And see, so there needs to be a way to improve which ends we're going to use. So we know that every single n is going to be at least... God. I can't... I know there's like a simple trick you can do to speed that up, but I'm just... Let me think. You're basically gonna do, you know, so you're gonna do like a unsigned long t equals some variable. We'll adjust it later, and then you do let's do a bool found. Make something easy. Bool found equals you know, false. Do while, you know, not found. You do some logic to check. So I basically do if so I do do found equals true, and then you do the for every single value in the schedule. You if so what is it? If your found value for t well, we need to do another. We need to do it anyway. So for I equals 0. And you do if v minus t mod v does not if it doesn't equal I, then found is false, and we break. And we break. So this is fairly easy. It just tests if the t you have is valid. But then you can do, you know, this t you need to do it plus equals something, and that plus equals something can be some smart value, which allows you to very easily find it. I was going to call it like increments. And this t will start out as some n of this increment already. And this will be like, you know, 10 times increments. Yeah, so that's where you need to do least common multiple. I'm just thinking, so that'll be the least common multiple of of your three values of your things, but I'm not sure this plus is used somewhere, because that would be 17 times 13 times 19 is way too high. And that's the issue, because it's the least common multiple of prime numbers is always a coprime. And I think we've had something like this before, because you're looking for a series in a coprime, like the repetition in a coprime. So what's going to be the least common multiple of the largest you can get? So that would be like... Yeah, so there needs to be some kind of... boy, let's see. So normally I would say you need ones that are 0, but that plus there, I just still... I'm not sure what to do with that. Because the thing is, if I solve this this equation might not be necessarily true for that one. But the least common multiple between those two is going to be 17 times 13, which is 221. Which would be the value for that one, but there's no... damn it. There's gotta be like one tiny line here that's super simple that I'm missing. So I could also put the T on the other side, so that you can do like it's basically going to be n times 13. I think I'm... yeah, equals t plus 2. Which can do t's minus 2. Man. I'm missing what to do here. Because there's no sense in just multiplying these together nilly-willy. There needs to be some kind of logic behind it. Let's see, so t plus 2 plus t plus 3 is gonna be then when it's like... I think I may... let's see, so just gonna rewrite it a little bit here. Because we have like these two, for example. So these are gonna be equal to each other. So you... and this is gonna happen when t plus 2 like times 19 equals t plus 3 times 13. Or sorry, times 19 times 13. No, but that's not possible because you're saying t plus 2 is equal to t plus 3. That's not right. the value that must adhere to this. So what we do is t plus 3. So for this to be valid, yeah, it's this plus. Like if there was no plus there, I knew that t would be the multiple of 13 and 19, but now it's slightly different because it's gonna be man. Because I could rewrite it the same way I did before. T plus 2 equals... that's how long it will take for the penny to drop. At least that probably is going to be n, you know, times 13. And the same goes for you. I'm just rewriting what we did above as well. Maybe in this way it'll, you know, work out. It's n times 19. So we know which n will be valid here because it'll be the other value. No, because then I had before that doesn't work. That's literally what we wrote above here, basically. I don't want to go back to just here because then I'm just getting nowhere. So the difference between these two is like 1. So you could have like a t like, you know, this equals t plus 2. So you can rewrite them fairly easily by doing, you know, just rewriting in that, which would just be t prime. And then you'd have like t prime. So that they're all like, the problem in that sense is the numbers in and of itself are not relevant. Because you just get this, t prime plus 1. But can I just not add 1 at the end, basically? Just find the coprime value, which would be just 13 times 19. But like I tried that route before and it just gives me 247. But then this plus 1 doesn't work. Man. Because least common multiple, when I add this to this value, that doesn't work, because then they're no longer prime. And multiplying them all together, wait, do I just decrement then? Do I just like search down? Because I know that that'll be an upper value. So we know that 19 times 13 times 11, sorry, 17 is 4199. Betting on 3F, thanks Aftish. And then we just decrement, we can search. We can start searching below that. See, 3, 1, 2, 3, 7 over 17 over 15. No, that doesn't work. 11. So this will be an upper bound, basically. But that'll be, I don't think this will be, you know, a good way to do it, because here, you'd get like 6, 7 times 7 times 5, 9 times 6, 1. 2 million. So they'll see that's way over, like over double. But it's still an upper bound. Actually, it might not be proper. Because for our input, we'd have 29 times 37 times 13 times 19 times 23 times 3 times 41 times 17. Okay, that sounds about right, though. Okay, so this is an upper value, but it's still going to be like, you know, this for my input, which is ridiculous. Boy. Yeah, so like this value. Let's see. Oh. It's really those pluses and minuses that are throwing me off. It's really not a hard problem. That's the frustrating part, because I know that like I have everything I need in front of me. There's just one penny that needs to drop. 3 times 20. Wait. 3 times 7. I was like 201 minus 180 is, no, 201 minus 180 is 21, but that makes, there's no sense there. The difference between the values is normally 2 is 5. That's nonsense. Oh, blast. Okay, so let's go this way. So subtracting the value makes no sense, because we know that if we go to our example, like we would be subtracting more than 17, it will be a negative number. That's nonsense. So subtracting is useless. So that's not gonna be it. Addition, because we basically want the cycle to be perfect when we add it to the start, because it's an offset. And that offset allows us to check 1t for every single one, and then we need to increment it by at least the smallest value, which is going to be like 683 in our case. So the highest value is the last one. So what we would do is we'd kind of transform it, because then we can define it as an n times whatever its values we need, because that'll be the fastest. And then we know that the incrementation there is going to be that times its second largest one, which would in this case be 19 times 13, which is 247. And the proper answer here was like 3417 over 247. Doesn't work because we need those offsets. What I could do, however, is change the value what we need there, which is going to be what are the 3, which is 3417 plus 3417 plus 3 over 19 works. Oh, 3, 4. Could you actually give me the value I want? 320 over 19. Oh, 19. Wait, what? Oh, damn it, it's doing the freaking calculations wrong. But that's 180. But over 15? No, it will be like 13 is what we're gonna do. Over 17? It's not a whole number, yeah. 3, 4, 1, 7 plus 3. Man, I'm not entirely sure. So we could always just do, like, it'll be the largest value. So that'll be fairly easy. Just do, we can find a max here, you know, 0. And we do else if waiting. Do it here. If the v is over max, max equals v. So that'll be our first increments will be max. So one thing we could do is do so first you'll be max. Actually do a minus, so we could do an upper bound, which will be all of them multiplied together. So that'll be just do an unsigned long multiple equals 1, and this will be a multiple times equals v. So they'll just multiply them all together. So this will just be multiple, and then which we don't even need to do anything. So just do like multiple. And then you use this count multiple. So this will work here, I'm pretty sure. I think this will work here. The only issue is, so we're gonna ignore part 1 answer. Will that even work? Oh yeah, because I need to reorder my logic then. Because basically what we're doing is the minus I there. So first let me just do count multiple, just so we know we're actually getting past the right value. I know we're not doing the logic check correct, that's fine. I'm just gonna cancel this basically almost immediately. What the hell? Is it? Oh, it overflew. And actually now it'll break fairly quickly. So we should see the right value here. 3417. No, it's for 3420. That's the value we're looking for. 3420. I also need to max dex basically. Oh, there's no max dex there, damn it. I need to find the index of this. Because I need to know which I it is, at least, so... Damn it. 0, I is less than schedule, stop size. I++, we'll do v. Just get rid of you. There we go. Stop complaining. You know what V is. I mean, identifier V is unidentified. Oh, well, that's why. There you go. So it's gonna be like minus max dex. I need to rewrite this a bit. Although modulus is probably the smartest way to do it anyway. Anyway, so now well, it's gonna be I minus minus max dex, right? But it won't give negative moduli, because what we're gonna do here is like, okay, so we have 3, 4, 20, 3, 4, 20, mod 17 is gonna be 3, which is fine because it'll be 0 minus 3. Yeah, you just do minus 1 basically. So I plus 3? No, because this will be, just so I know, so this will be like 17, so it'll be 17 minus 3. Wait, what the F am I doing here? Don't need to do this V crap. Oh, this is the time. So this will be 7 minus 3. 17 minus 3 is 14. No, that makes no sense. But it's 3 away from the maximum value, so that's why that works. So that'll be V minus. No, because then I'll just do this basically. No, because that makes no sense either. I also need to keep the I minus this, right? Because this will be 0 minus 3. That won't work either, I think. Huh. I'll find a wrong value, that's for sure. I'm doing something wrong here. Yeah, it's because I is an int here. It needs to be something else proper. Oh god, my brain is turning into mush again. Hey there, Rally. Watching me struggle here. This goddamn arithmetic, man. Ugh. Let's see. For logic here, 3, 4, 20 modulus 17 is 3. We know that the I is 0 and the max stack will be 3 here, which means that that'll be 3. Oh, wait a minute, you can just do V minus I. Yeah, so just kind of do this back. Because this will be multiple minus... what is it? Max dex? I think this will be the one. No, it still doesn't give the right answer. I'm struggling a bit here with being very with this. Let's see. So we can actually set this. Just set multiple to the correct value. You can see what happens. Multiple. Yeah. Well, the thing is, a few guys in my Discord, they said, "Hey, we figured it out." Not map multiple, thank you. Something was, I know they're primes, so I know you can speed it up with some least common prime stuff, but I'm still doing a fairly naive approach because I know the upper bound of the value, what it can be. But I want to do, yeah, like I know what the least common multiples are. I know, how that works, but the pluses there are throwing me off, and that's the issue. And that frustrates me a lot because I know that the solution is like right around the corner. Wait, why does it not? Yeah. So you have, because you have like the. So this is the formula you're trying to solve. Basically, you're trying to find an n, which is for which this is true, and the n differs per step. But it's like you're trying to solve this equation basically. T plus 2 modulus 13 equals T plus 3 modulus 19 equals the other one, which is in this case T modulus 17. Sorry. Which will be 0, 0, 0. That's what they're all 0. So if it was simply, if this was 0, you know that this number needs to be the least common multiple of these three values because they're all primes. So the value they produce is always co-prime. But these pluses are throwing me off because I'm not sure how to handle that within within that basically. Also, why are you giving me a single value? Oh, yeah, if it doesn't equal found as false, break it. Yeah, of course. So the first one is 2. 3417. Count multiple. Oh yeah, so no, because the number I would have as a right answer would be 3420. Why is it 16? Because it's 1. I'm doing, so I actually do max x will be that's I, so this should be 3. Let me see if that actually works properly. Max dex is 3, right? What? Oh. There we go. Don't tell me I got that. 2? What do you mean 2? 0, 1, 2, 3. What? Oh, I see. Oh no, that's fairly easy. It doesn't count the x's. Oh crud. Oh boy, I need to actually store. Ah, crap. I'll need to change that. That's annoying. That's really annoying. I need to change my storage, of course. I guess the greatest issue with today's problem is that you can't really use the examples of good measure how good your code is actually entering part 2. I already know that the chance is pretty big that the upper bound is not very close to the answer, which means I'll need to do it, but I want to try it anyway, so that's why I'm fixing that. So this will be pair int comma int of I comma to I plus plus comma. Actually, no, don't do that, Nitro. Don't do that. That's bad. And then we do I plus plus. There we go. So now what I can do is start second, and this will be it'll be a schedules I dot first. There we go. The mindex is just the value of v, so that's fine. Yeah, so that already explains a few. So max dex should now be sort of correct. So now it's 0. What? Why is it 0? Just gotta make sure this actually gets done properly, because that doesn't always work that way. Now it's 3. Good. So yeah, now it's 17. So so if we just do this, now it should be 0. Yeah. So this should be 0. I'll be checking all of the values, so this should be 0. Yes, not done. Expect an expression. Oh, one more bracket. And now it's like you to count this every single time. Wait, what are you complaining about? What are you on about? Oh yeah. What a whole lot of bunk. There we go. And the same needs to be done here. Oh no, just on the other side. There we go. Anyway, like I know that I'm so damn close to the correct answer, but it feels very frustrating. Wait, so if it's 0, oh yeah, if it does not equal 0, it's the other way around. Let's see. So I'll actually get rid of this count. So we don't need to know max stack. We don't need to know multiple, because we know multiple will be fixed at 3, 4, 20. Actually, okay, we can actually keep that line. Just count it out. 0, 11, and then it's just count multiple. Yeah, normally it would break before, so that's fine. So it says 3, 4, 20. Yeah, so why are you 11? So let me see. Oh, no, that makes sense because... Wait, why did that equal 0? What? Oh, no, that makes sense. But yeah, you should be max deck. Oh yeah, plus I think that will solve that. No, so this is going to be the other value. So this, yeah, this is going to be do we use V a lot? Nah, just do so we don't even need this anymore, really. We can just do for pair int, int v schedules, because we don't need I. Actually, I is going to be so this will be v dot second. This will be v dot second. See, the influx people isn't helping you. No, it's putting more pressure on me. And this will be v dot first. Makes me feel even dumber as usual. So this works. So now actually we need to do this only if we you're in comms exactly. Just do if found. Just do that. So this will now give us the right, it'll tell us, hey, this is actually correct. Now if I remove the preset multiple, we should still get the same answer. Yes, and then we just do that minus max dex. And this will be the right answer here. Wonderful. The only issue is that I have a feeling it's going to be super slow. So let's try it for one of the other ones. So this one, for example. And let's get rid of the other ones. And it'll tell us 7540118. So this is correct. But I have a feeling it might take way too long for larger examples. And I know that this can be sped up way. Okay, it's still 112. Still gives the right answer. Let's go kill myself and try the actual answer. which I don't think, well, that'll take a goddamn age.5. So let's see if it works anyway. It'll tell us how long it's going to take in a second. While this is running, though, I can think of ways to speed it up. Enough time to download I already downloaded Cyberpunk. What do you want about? Oh, 2 hours? No, I don't think it'll take 2 hours. But I mean, it should never take more than half a second to run. So this decrement. So we know. Let's try a few things. So we know we're gonna keep working with this example. So we know that we get 4199 minus 3417. What's the number we get? We got 782. 4199 minus 3417. And this will be 782. So 782. That's 46. So that's a whole number. 782 over 15. 19. But we know that like the other answer is going to be like, so 4199 minus was it 3420 is going to be divisible by 19, 41. So we got and then the other one is going to be 4199 minus, was it 3341 3419 over 13 is going to be 60. So that gives us numbers. They're whole numbers, which shows we're doing something right, but it's still how do I use that to get to the answer? Because we get 40, what's the order? 46, 60, 46, 60, 41, which makes sense because these are of course the larger, smaller numbers and such. But we use the answer to get to these values, and I need to do it the other way around. Anything? These are all, yeah, they're not all. So this one's odd. So that's not a thing. I don't think I can do anything with these. What's the greatest common divisor? It's useless as well. Are you winning, son? Well, we're running a program that in theory will give us the result. I think it's doing something at least. I think so. It gave us the answer for the even the largest one fairly quickly. It gave the correct answer, but the issue is that it's so much larger. It's basically doing a naive search that is... Yeah, exactly. That's my thought as well, CFusion. I can leave it running, though, while we're thinking, because I need a better way to do this. So the thing is, I know this is the distance between the answer and the wrong one. So we know that 782 over 19 is going to give us... Wait, 782... Oh, yeah, sorry, it's like 41 is the amount of steps we need here to get to the right answer. I have a feeling the answer to get there lies in the other numbers. But anything adding or multiplying together doesn't work. Can you solve it in just two? Can you solve it for just two equations? That might be an alright. Well, so say we have 13, 11. The answer would be t modulus 13 equals 0 and t plus 1 modulus 11 equals 0, which means you have t modulus 13. So we know the upper bound, which is 13 times 11, that's 143. So in theory, we could count down, but we don't want to do that. So what I need to do is like t modulus 13 equals t plus 1 modulus 11. And I think here you can do something. And I think it's going to be times 13. So 13 times 11 is 143. So we know that t modulus 143 is going to be 0. Okay, this is the same as t times n 0 over 2 modulus 13. Mod is the remainder. Which means that t equals n 0 times 13. And t plus 1. Stuff without numbers. Okay, but so you're gonna have like P1 and P2. So you have P1 and P2. This would be P1 times P2. Just stands for prime, by the way. So you would still have so this is the equation we're trying to solve here. And the thing is, you're just gonna have like my condolences to all the raiders. You should have come on a day where I actually finished my code earlier. And then you're just gonna have like that. So this will be like ... and ... So it's gonna be like the least common multiple minus the offset times that value? No. Because I looked at something like that before, and if we took like 4199, like sort of like 3 times 19 is 57, plus this is only 13 times 2, 83. 26. Wait a minute. Is this just a coincidence? Oh no, 57 minus 26. No, yeah, I was off by a bit. No, I was just not looking right. So I go, 57 minus 26 is 41, right? No, it's not. It's 31. But close guess. This is the programming challenge. Yeah, look, it's still going. It's not going to finish in a reasonable time. I'm pretty sure it's going to be very slow because it'll do about 1,000 per cycle. So the break condition, we know that it only is valid when it is a math challenge basically. It's not a programming challenge. 1,000? That's way too small. What are you on about? 1,000 is way too small? See, this is kind of where I'm stuck. I don't know how to further simplify this. I was interested in these kind of things. I would love to do these things, but figuring them out myself, like I'm just, it's been so long since I actually worked with maths in such a way. So we can also try to find these numbers programmatically. So we don't look for the proper answer. We look for like these. Actually, didn't I say that I would do that before? Yeah. Because we're basically trying to find... Yeah, that was like we're trying to find n0 times p1 equals n1 times p2. Oh, actually, make this do this not the stupid way then. Plus 1. Which means that if they're equal, then we can subtract them to be 0, which means of course that n1 times p1 minus n2 times p2 all equals 1 actually. And we know that so we know that the value here is probably the coprime of these two. So if I said that would be p1 p2, so we basically get p1 squared times p2 minus p1 times p2 squared. Which is basically, you know, p1 p2 minus p2. Ignore the code switch, please. And this will be the p1 p2. And these brackets can be removed, but this is the same. So this will be p1 minus p2 35. I got rated by someone, and for some reason people stick around to watch me do mental gymnastics while my program is not going to finish in the background. So what we can do is p1 minus p2 equals p1 p2. Wait, what? Oh yeah, 1 over, but still. You were doing gymnastics. Exactly, mental gymnastics, they're great. But this is nonsense. This is utter nonsense I'm writing down here. And this is not even generalizable, really. Chinese theorem. What the hell is a Chinese theorem? Bang my head against the wall until I get an answer? It's just stuck at 0% CPU. Probably they're very simple operations. Anyway, just stop that. Get the question right or we try for a new sun. It was actually doing stuff right. Yeah, so the issue, as you can see, the value it's looking for is huge. And it's going down very, very slowly. What the hell is the Chinese theory of remainders, hamster? How would I know that? I'm not a mathematician. Oh look, it's actually it shows you that it's printing, which takes time. What the hell is the Chinese theory of remainders? I have no idea. In theory, we could just nuke this. It's useless. How would I know it? Chinese restaurant, thank you. Yeah, why am I not a mathematician? I don't know. If one knows the remainder of the Euclidean division of integer n by several integers, one can determine the unique remainder of division by the product of these integers on the condition that the divisors are pairwise coprime. Yeah, that's kind of what we did. But now yeah, okay, to eliminate the remainder of the division of n by the products. Do we care about the products? We know the product, of course, these integers. Knows the remainder, but we know the remainder, which is going to be 0, 1, 2, 3, 4, 5, etc. 1, 2, 2, 2 minutes, n. The remainder of the division and by the products. I really didn't want to look it up, but no, thank you, hamster. Let's see, yada yada. I just go to the programmatic solution. Where was it again? Station. Compute the remainder to find a solution. Yeah, it's very easy to check if it's one, but we don't want to do that. Search by sieving is basically what we kind of want to do, right? Let's see. Imagine needing to cheat. I don't know, man. Let's see. So this is kind of what we did. We just did it the other way around, sort of. Value of these numbers modulo n2. One eventually finds a solution x2 of the first two congruences. Faster the order might have been ordered by decreasing value. See, they can proceed by adding 20 as 5 times 4 at each step, computing only the remainders by 3. This gives 4 mod 4 0 continue. Wait, so how do you exponential time complexity and therefore is not used? Okay, so what do computers then use? Yeah, I'm not sure what the smart way is to implement this anyway. Interpolation. Got the ring theory go away. No. I have no idea where to actually look inside here to because that's computation nice. So probably should use the edge linear Diophantine, maybe that one. Less efficient than a preceding section. So existence construction, what do we need? Or is last semester I don't want to see the word Diophantine ever again. And I'm just glad I'm just doing biochemistry and not any of this crap. So Bestwood's identity, that's something we need to know first. Let's see. Get two moduli. It's just 2. We have more than 2 though. For more, the method for 2 models replace any 2 congruent single congruence model. It provides eventually a solution with the complexity which is quadratic in the number of digits of the product of all moduli. Jesus Christ. quadratic in the number of digits of the product of all moduli. The product of all moduli is like this. That is not time efficient at all. What method do you use on Hamster? I'm already way past, needing help, so that doesn't matter. And I'm pretty sure this solution could work fine if I use a smarter value for this, but of course I need to use a smarter value there. Oh, the program would run fast without. No, and it doesn't matter. We ran it for like 15 minutes without printing, and it won't ever find the value. It's really not. This is not a good way to do it, because this max is like 600. Could you go away? It's like this value, like 631. And I'm pretty sure you can find a better value that's way larger to do that way. But I've tried to do like the math here. I know it's in hundreds of trillions. That's why it's not relevant to do subtraction with such a small value anyway, because it won't find the right answer in a decent amount of time. I remember in Python you had something there, but like what we needed to do with another modulus math problem was like use POW. Yeah, it's huge, the answer. It's like POW x y something. It's like modulus stuff. It's like power -1. I remember something like that. It's like modulus power. So it's like x to the y mod z, something like that. You could do that easily. Yeah, it was something like x prime. That did something. If it was if they were coprimes, which they are, but I don't know how to use that efficiently here. Like, what values do we use? The multiple of them all with the. Like, your answers are extremely useless to me, but thank you. What was that again? I'd like to still figure some parts out myself and not just jump to your code just to copy it. Yeah, it's because I canceled it. I'm not so entirely sure how to use the POW there. So you have the list of mod and remainders. Yeah, we have the list of the mods and the remainders. And I know, like, someone mentioned like the Chinese theory of remainders that I have here, but I'm not sure how to actually implement it. Okay, I know this concept works. Sure, it must for this problem to be solvable, but I don't know how to properly implement the search for that. That's the issue. Because I know there's some sort of semi-recursive search crap you can do. Like what they do here, but I'm just not entirely sure how to actually do that. Look at the proof general case section here. Should be a big hint. Consider a sequence of congruence equations, A mod n1. Yeah, when ni are co-wise prime, the two first equations of the solution A1 provided by the method of the previous section, set of solutions for those two first equations. Yeah, I knew that, roughly speaking. All the other ni are co-prime with n1 and 2. This solves the initial problem of k equations to a similar problem of, yeah, it gets a final solution. Okay, yeah, actually, right. Beziewicz identity inserts the extent of two integers. Hey, what was that we had here? I remember, yeah, I got So I was getting close. Extended Euclidean algorithm. What? Given by an A. Yeah, I remember. So I got some nonsense here. About, oh, these are co-prime, but then they're not. That's not, so this is useless. But this is, we need to find a solution for this problem. So we can just ignore the first, we can just ignore everything else, I guess. So we just need the first two values. And how do you quickly get Basewood's identity? Wasn't there, so that was what you used the POW thing for, right? Crevens. With greatest common divisor D, which is 1. So we know because it's their co-prime. Since A, X plus B is more generally accepted multiples of D. Yeah, the extended Euclidean algorithm. Yeah, you're right. Extended, that's probably what I should look for. Instead of just searching through it myself here. Let's see. What's the extended one? So yeah, it's 1. Yeah, it's recursive crap. So we can just ignore that. GCD minus B over A times it. But I think you can speed this up because we know that the greatest common divisor in the extended one is 1. You think this is getting necessarily? I didn't need any of. I know. It's the theory behind it. Yeah. But anyway, I tried to prefer not to just grab the resulting code. That's why. So I need to find 2 answers to base with identity. We can clear an algorithm. So the results. So yeah, that's. I don't care about the greatest common divisor though. I'd like to find, you know, this A and B value. The XY. It returns GDC. Yeah, so we want this X and this Y value basically. Man. We don't need any of this. I just need to get those 2 values. I'm gonna just copy this, which will be extremely lazy. But it could work. Don't need you anymore. But even then, how would we use that? So say we have those values. Solution is given by X, yeah, sure. So say we have those values. You just need to find A1 and A2. Applying that X. Sure, but how do we get those A values then? Then we need to compute those. And that was something with that POW madness. I don't remember exactly. Good grief. Fucking modulus math, man. I kind of hope we didn't have to do it this year, but I guess I wasn't spared that. Now we still need this one because that's the exit case. Results of reserves of call. Yeah. So I can basically do this, and then we know X and Y are our answers here. So that's the, yeah. And we know GDC is 1. That's always going to be the answer. No, it wasn't. It was last year was way worse. But the thing is that my brain doesn't work with my brain just doesn't work with this at all. I'm not good with that kind of math because it's just something I never use. Brilliant's Chinese remainder theorem article is much more helpful and help out to compute the congruence. That's initially, like, I understand the concept here. I just no idea how to approach the computation properly. And sure, I can use this, and X and Y are the values we need. Because I could just copy this. And then we can just go away. So we just need to do none of this crap. Just return 0. Yeah, I'm just not gonna bother with, not copying anything. There we go. No, there's no bot here. Still no bot here. Yeah, so A is gonna be like, would be like schedules index 0 dot seconds. What kind of bot did people even make for this? Yeah, now we just call GDC extended. What are you complaining about? Oh, because I can't spell, that's why. Computation is just a linear check. I couldn't find an equation, you just plug and chug. I mean, I don't mind linear checks, I just know that I can speed it up so much more. The answer is easy. My answer is that whatever the CCCP tells us is gonna be the answer. What are you complaining about? Oh yeah, it's just name it B. First of all, yeah. Wait, what is your B? Oh, B, yes, that's so. We just call you a C or something. I don't care. Just call you X underscore. Not be sloppy here. There we go. Let's see. Minus 1411? What? First of all, let's actually put this back to the what we had here. There we go. What is it minus 3? Oh, because they can be negative, right? Yeah, of course they can be negative. Do. Because remainder is 0. So we can get that, sure. But then how do I get it here? Let's see, sieving. Because they do say, okay, he'll know, so you can, sure, you can get the Baselitz identity. I think they mentioned that here as well, somewhere. Here. It's a quadratic linear, sure, great. The 3 and 4 is 1 and minus 1. Putting this into the formula, proving the existence gives 4 plus 0. What? Why did they have 4 times 0 here? So now it's basically not a recursive, but it's just an iterative search for the answer. I'm still not entirely sure how to apply this. Putting this in the formula given for proving the existence. What formula for proving the existence? Oh, it's one up there. The illustration is being obtained by adding -9 to any multiple of 3 is 4 is 12, so you can get it plus 12. So that's the multiple of that. This is 3 or 4 is -1 minus 1. I'm still not entirely sure which formula they're on about here. That's kind of the frustrating part here. In the formula for proving the existence. Oh, here, existence, direct construction. Let any be n over e be the product of all moduli but 1. So if you only have 2, that'll just be one of the values. But to 2 minus 1. Good gods. Okay, I still don't know how to approach this properly. And I don't want to spend 4 hours on this again. This is very frustrating still. Let's see. So I get those. Solutions. Yeah, I don't want to spend ages here. I think I'm just kind of done with this. Wait, your solution just doesn't increment by 1. How is that fast at all? Oh, increment. It's okay. We can't think any less. Thank you, CFusion. Appreciate it. Okay. Oh no, I see the increments you do there. Yeah. Yeah, I see what you do. Let's see. So your solution is way different. Yeah, you don't use that at all. Yeah, I know why. I know why, because what you're doing is you're saying, okay, if it's not the right answer, we need at least another multiple of at least another multiple of this number. Should you, if it's there, times 10 plus I, which I is, oh yeah, that's your range, yeah, so that's your the index there. Okay, so fine. So let's implement CFusion's method here, which is not the method that I think Hamster uses, because I want to take a look at his as well, and at least understand the hell that I'm doing here. So let's just ignore this for now. We might need it later. MK, yeah, I know, but that's fine because you're. So this is his solution. I'm gonna put it on another monitor and just transcode it here. I still have the information stored elsewhere, so that's why it's fine. So what he does is timestamp starts at a point, but I'm gonna start it at 0. Just so, because I'm not sure, you have a 9 at the end. I think you do it because you keep something else there. Anyway, so while true. Increment. Oh wait, no. So did you? Yeah, you kind of do the same logic I did there. No, you set it to start at the set of everything. Yeah. Yeah, so he has to like the multiplication thing, but then in a smarter way, because we know if it's not true for, so for any value it's not true for, it needs to be multiplied with. Yeah, so that makes a bit of sense. So what he does is bool flag equals true, and then he does for pair int, comma int. I'm just going to transcode it and then I'll explain it. P in schedules. What is it? Inst offset equals timestamp plus p dot first modulus p dot second, and they do if offset does not equal 0, flag equals false, else in increment times equals p dot second, if flag break timestamp plus equals increment. So, and then we do count timestamp here. Technically, don't need to reset, but I do because I'm lazy. Yeah. So this just to show it works, or to see if I coded it properly. We got the right answer. So what you do here is, let me just minimize this. So this is the check if it's correct. So you know, if I did the same check here, basically if you need 0 to be your modulus. If it's not 0, it's correct. It is a naive correct. I was so close. Like I think because I did the break here, which was stupid. So first of all, what I could do is I could set multiple to 0. So just to adjust my selection, you know, I would literally do plus equals. So we had a max focus as like the other one, so we just do like an so just the increment value, which is slightly different. So this addition here, he sets to 1, and then instead of breaking, he does addition times equals p dot second. This was all what that would be needed to fix my solution. I can check that by doing this and seeing if it now works. I think there's some overflow there. Oh yeah, first of all, you need to be just multiple. Now it's 0? What? Just to keep it from addition. I'm doing something. Yeah, flag is true. So what am I doing wrong here? I think you're. Oh yeah, you shouldn't be max stacks. You should be. Timestamp plus. Yeah, there we go. Still gives 0. It's a bit weird. Why is it not right? Int offset is timestamp, which is multiple. Actually, just literally just rename it to be proper. Why are you complaining about timestamp? Twice times. Oh yeah, that's why. This is literally so it doesn't get added at the end, basically. And just do can actually use the increment as well. So why is this not working? I think it's something is going wrong somewhere. Oh, so now it does work. Okay, so so this it was fairly little adjustment that was needed to actually fix my solution, which sucks because we were so close. So the way, so see, Fusion's method is the same in principle, but he realized that if you did so, if you're yeah, it's very simple. It's like if you found it, so if you, hey, I know this is actually a correct solution for at least one of my values, you just add it on, you multiply it. So it's because of the least common multiples thing. So you know, hey, if my if 3 of my solutions work here, then if 3 of my solutions work here, then I know that the right answer will at least be another multiple of these apart, you know, advanced. And that allows you to not just decrement by what I did was just the highest value. Because what I was doing was basically doing one and only increment, doing this with the highest value, max. But now you are hundreds of times faster because you're multiplying by hundreds of values. So I can just delete his solution. I think I need to scrap for Hamster's one because I still would like to actually like to do that. I'm just going to delete this crap since it's really not needed. And then put in the right solution. Quick, delete the evidence. You guys didn't see anything. The frustrating part is that I was fairly close, but I didn't realize that because it is that's clever. And you just instantly find the solution. I'm a bit annoyed I didn't realize that myself. But you know, I needed help multiple days. It did technically see. Well, I mean, yeah, I know. It's just the thing is, it's one of those, it's one of those things where if you realize what you're doing, it's so much easier. Oh, see, these are the cheats that Hamster used. Hamster just entered in the values here. What do they have? 29, 37. These are the largest ones, right? Basically, 631, 383. Wait, integer number modulo n. Oh, that's just the a minus 1 mod n thingy. Yeah, that doesn't count. Where's his code? Huh, that's an interesting one. So this is list. This is the sum. This is what Aftish did. So this is the sum. So here you do. There's a harder cheat. Yeah, I remember you mentioning that. I just feel frustrated that I didn't figure this out myself. But I didn't do it last year either, and so I'm not going to be too sad about it. Even then, I think in general I cheat between quotation marks 1 or 2 days every year. Where I need any help. Let's see, he reduces. So this is just a multiple. So he does it for, I assume this is the incrementing. Floor division. And then 0 plus. Yeah, he does the power, the modulus power as well. So any value to the power of -1, modulus, it's modulus for all of them. And then you sum. Should have written a random walk solution. Fucking 7 billion humans, random walk solutions, they're great. Sum list B keys. Let's see. So yeah, B is the keys, so those are the. I assume those are, yeah, those are his original values. Might the same as Aftish. All right. Yeah. So it's fairly similar here. So we have huge number is 0 because Python supports that. So for I in the delay, you should do huge number. You add, so which is the sum part here. What is your eyes? Let me see. What the fuck is the eye here? Crivens. I in Bustele. Bustele is what exactly? Is that a list or a dict? Bustele, here we go. 0 times 2 for I. Oh, and then you fill it in. Yeah, you fill here in Bustele. Okay. Do the multi-I, which is... That's just yeah, that's just a sum of, sorry, the multiplication. What do you call it again? I know that the signal is a pi, a capital pi you use for that, but I don't remember what it's called again. Anyway, the multiplication of all delays together, floor division times that inverse modulus pow, and then you just subtract from the sum. You subtract a huge number modulus the sum. Which is the same thing that Avtish did here. Sum that huge number modulus m subtracting there. The thing is, I don't think I would have figured out this way myself. I think I would have eventually maybe arrived at C-Fusion's solution, but I wouldn't have figured out this one. My modulus math is just too rusty. As in, I've never used it. Hamster solution required. No, I mean, it kind of. The thing is, if you realize the what it is, the Chinese the Chinese remainder theory, I would have never thought of it as myself because I didn't realize what it is. But if you did, like the prime thing, I would have figured out because I generally check after that for a while, but it wasn't needed so far. Then you would have, okay, you've noticed they're prime there. Then you could think about, okay, what things are prime? And I may have remembered it before. I learned little Fermat's theory. Like, we don't learn that here. I don't know what, I know Russian schools are like insane. But we don't use, I never got this. I realized they were prime doing LCM calculations. I would have realized that too, because I was going for like, least common multiple. You know, if they're not primes, then there could be a smaller value, and then like, wait, no, they're primes. They don't have a smaller value than that. Yeah. So a to the power p is a mod p. And a is not divisible by p. A will never be divisible by p unless it's 1. There you get this one. But yeah, it's this is another one that you do. So use CRT, which is, sorry, what is CRT? Oh, Chinese remainder theory. Yeah. So let me see. Part 2 pairs is whatever. Is this? Yeah, this is Erlang, right? Or not? No, it's JavaScript. It looked a little bit like Erlang, but I'm just I blame Nix for that. Yeah, pairs.reduce. So you reduce result.pair to CRT result pairs in the first value. So you do lowest multiple greater than. So where do you use that even? Oh, use that here. Yeah, that one was fairly easy. Which is .I be 0 while. Oh, and that's just finding. Yeah, that's just finding. I was thinking about doing that as well, like the naive solution, because when I was looking at how to calculate this, basically, you could like this is basically the way to calculate that. Could you not freeze? So you want to find this value. You're basically doing this. Because it's, what was it, this one? Like kind of doing this. Sort of, I think. AC really expanded my horizon of professional use languages. I mean, in theory, any Turing complete language can be used for anything, so. And very often you're limited by other stuff. Like, for example, in my professional, between quotation mark work, I'm limited to Java because that's what the plugins that I'm writing for software, my software I actually used in. Just for reference, if everyone has ever used, whatchamacallit, ImageJ, I write plugins for that for my thesis right now. So I'm doing everything in Java. Would prefer to have something else, but well. Anyway, this one's pretty simple. So, well, smart, I mean, because you're basically finding the solution to the Chinese remainder theory for every single pair, which makes sense, because that's basically what you would do, because you reduce any two pair to one singular value, which you can then use in the next calculation. So, if I had banged my head against this Chinese wall, I probably would have come up with something similar in like 2 years or so. I like that there's multiple ways to get here, because I think CFusion's solution is the naive one that most people would have found. So I'm glad to have found more. So for your timestamp, what did you actually? How did you get to the 10009 thing? Let's see. Well, we can always take a look at the Reddit, see if there's anything there. Whole bunch of crap. And we'll see if there's anything here weird. Okay, that's pretty. It's the first valid timestamp has a really large number. Wait, what do you mean valid timestamp? Any timestamp is valid. Oh, you mean the one that is an increment of your smallest. Yeah, I see what you mean. It's the one that it's basically your answer for the first problem, basically. Yeah, exactly. Modulus first number is 0. Yeah, exactly. That's fairly easy to find, I guess. I wonder why. Past 4 hours. I mean, it's a bit excessive since this is the morning, but... Let's see. Get a new percentage of highest number to skip the most. Yeah, that's what I was thinking you would do. Modulus of highest number. But you're not going to skip much more with that. You're going to skip like 500 values, which is literally going to be one iteration. In, theory. Solution in Lisp, I'm scared. Go away. Go to the top, please. However, I have heard of Wolfram Elfstar word a short program to generate this. Jeez. Just... Oh my god. If you're smart about how to... Yeah, sure. Oh, that is... Literally just... Here are 15 values. Please just solve it for me. That's, that works, I guess. Yeah, I mean, it's pretty smart here to use. Especially because it is so short, you can just hard code it. Yeah, it's pretty smart, because it's like, 10 file, it's like, what, 10 or so equations. And you paste it anywhere and you get the answer. Pretty neat. Yeah, this is trying to see down. Why are you using 2 chairs, my dude? Let's actually take a look at who solved this. I'm pretty sure I'm gonna be slow as F here. F-Dish, Marvin, Hamster, CFusion, me, and then Stimart did only part 1. What a day. Anyway, I kind of agree here. The first, like... CRT is fast, but you don't need it. Turns out a lot of people were dumb like you. Exactly. Playing D&D right now for Discord. I rolled 2 ones on a mysterious scroll and sent the party to hell. Nice. Russians dooming the world to hell sounds pretty familiar. Anyway, I don't know what to say about problems like this for Advent of Code. On the one hand, I like learning about problems like this. On the other hand, it is something that, personally, I wouldn't figure out that easily. Like, if I would look at the Reddit, I see Chinese number theory. Assuming you need Chinese number theory just means I don't know how to least common multiple. Well, the thing is, that's the way you're supposed to solve it, CFusion. Like, your solution is the one that I would have found, and one I would prefer in theory, but it's not a very intuitive one. Because this works, like the fact that this works is because it is a problem that adheres to the Chinese number remainder theorem. How is it not intuitive? Because this works is because they're all prime, and I know what you're going at. It's like the fact that works is because it adheres to that problem. So it would work if not prime. You would just need to calculate the least common. Yeah, but that's not what you're doing here. You would need to calculate that. But anyhow, I prefer this solution as well because it doesn't require you to look up Wikipedia or realize that it was a part of that. Yeah. Previous to derives the brute force sieving method from basic logic. Exactly. It's small enough that it's sufficiently fast. That's basically what you did. Let's see. Hey, look, it's a Chinese number theorem line thingy. Yeah. Oh, just, have it be coded for you by Rosetta. Just, hey, there you go, easy peasy. Oh, God. So this is the fast way you could literally do it. Go to Rosetta, Chinese number theory, copy, paste, fill in the numbers here manually. Bingo, bongo, you're done. Jesus, that is... Well, I mean, hey, if you want to be fast... Just... Just literally query Wolfram Alpha in your solution. Okay. That's pretty good. Oh, okay, I like that one. Today I'm feeling really lazy, and I just query it directly. Okay, I really like that one. Ah, what a day. Yeah, this is basically for Delta bus ID. Yeah, well, it's not there, and then multiply with the bus ID. Interesting. So here they increment the timestamp. Wait, what? How does this work? So so you have a delta bus ID. While times was delta, so while it's not the right one, you increment it plus that jump. So you're just finding the first right value for you. If you're finding the first right value for that bus, and then you multiply the jump times that bus ID. Oh yeah, I see what you do. You're basically finding your. Yeah, I think. Yeah, that works because you have each. It's kind of the same as the pair finding thing, but what you do here is you basically increment your timestamp with your jump because it's the least common multiple thing. Wait, you're literally finding the least common multiple of the current timestamp and your jump value. Yeah, that's pretty smart. Yeah, Mathematica is a language that's amazing for some of these. Anything else? Anything interesting here? Don't think so. Anyway, this is one of those days that just really don't. How do you say that? That really don't mesh with me. But I'm sure tomorrow will be better, right? Right. Anyway, I'm gonna take a short break. Apparently Python has a patch that solves this for you. Simpine theory modular import CRT. Huh, nice. Goddamn Python, what an easy language. Anyway, I am gonna take a break. I'm gonna eat some salad, and I'll be back with Cyberpunk in about half an hour. So see you then. For Advent of Code, for the people who popped in, thanks for watching. I do a stream every single day at around the morning, 11, 10-ish CET for the Advent of Code. And yeah, it's been going all right. Anyway, thank you for watching. I will see some of you at least in about half an hour. So cheers, and till then.